First of all, thank you for handing in the statistics test in a timely fashion. It's all graded. It should be all taken care of on Schoology, so hopefully everything is good with that. Um, as stated in the email, our next our plan is to think briefly and work briefly on recurrence relations, and then over a 2-week period, one test each week to get a practice full test. This isn't for a grade. It's mainly just so you can have some closure. And as I mentioned in the email, I tried to give you an idea of the reasons for doing this, but also the reasons for looking at this very last topic. So the last topic really fits into the discrete option. However, it was not treated in our current discrete options text that you probably still have. The more updated one that we use for further math treats these recursive relations. So in this short amount of time, basically I want you to get comfortable what recursive relations are, how to solve some real basic ones, and then how to solve kind of one advanced one, a very specific type that I'll go over later this week. I did provide a link to the options text. You might be able to find it a little bit more conveniently than through this link, but of all of the text, we're only going to be looking at Section B. And of all of Section B, we're only going to be looking at a few types of problems there. So I would encourage you, until you hear from me again, to maybe find this, read parts of Section B, maybe look at some of the problems, get comfortable with some of the notation. So recursive relations. I'm just going to throw out one basic example because you already know what they are to some extent. This is an example of a recursive relation. It needs to be represented where we know it has a starting spot. And then, from after that, we have some relation. In other words, how do we get to the next term? So here, it wouldn't be too hard to create that sequence or that series or sequence of numbers. If I know the first term is 1, to get to the second term, in other words, a sub 2, I just take a sub 1 plus 3, which of course is going to be 4. And then to get a sub 3, I want to go a sub 2 plus 3. And of course, that's going to be 7. So this is really just a fancy way of writing a certain type of sequence that we know, and it's called an arithmetic. Now, in order to solve a recursive relation, what we basically want to do is to find the closed end or the general solution, the closed end solution. And luckily, because this is arithmetic and we notice it, we know there's a very specific formula for that. That the nth term is simply going to be the first term, which happens to be 1, plus n minus 1 of the common differences, which happens to be 3. And of course, we can rearrange that. We're going to get 3n. That would be minus 3. But then you add this, you get minus 2. So that would be a nice version of the explicit or closed end or solution to that recursive relation. So this first simple introduction is just to let you know that you already know something about it. If it happens to be arithmetic, there's a very specific format that we've studied way back at the beginning of this course. If it happened to be geometric, the same thing. Well, you could probably guess there's a lot of others that we haven't studied. And so our goal is to kind of get you a little bit more comfortable with those other types. The other thing is to be able to read a situation, and from that situation, come up with your own recursive relation. And then if you can come up with that own recursive relation, the question might be, can you solve it? Here's another very famous one that we are aware of. And that is if we let a sub 1 equal 1, and I'm even going to call it a sub 0 equals 1, I can just say that a sub n is going to be a sub n plus minus 1 plus a sub n minus 2. And what that really means is we have a sub 2, and that's going to be a sub 1 plus a sub 0. Now I could have had the subscripts be 1 and 2, then that would be 3, not a big deal. So that's going to be these two added together, which is 2. And then a sub 3 is going to be a sub 2 plus a sub 1. There's a sub 2, add a sub 1, you get 3. So before you know it, we get this type of a sequence. And we know that is Fibonacci. We've played with that. We've studied it to some extent. But eventually, at least by the end of this week, the hope is that you know how to find the closed-end formula for this. And some of you actually already know based on your internal assessments. But that's pretty much what we're going to be working with. Today's really short video was just a quick introduction, so I can at least touch base with you. Basically, what we can do is look for some more specific information. I will probably point to a few of these problems to try, not as a big problem set, but just to get some practice. But the more you can do as far as reading section B and rereading it and study some examples, maybe send me a question or two if you have them. By the end of the week, I can prepare a short list of problems that you can work on, get to me, I can check, make sure everything's okay before we go on to just some practice tests. So hopefully you're having a good day, and we'll talk to you soon.